Alright, now that we've covered potential energy and kinetic energy, we need to cover the idea of conservation of energy. We've seen the word conservation before when we dealt with conservation of momentum. That meant that the momentum of a system is conserved and it applies the same meaning here. Energy of a system is conserved. The question is, what energy? So, like momentum, energy is conserved. That means that the energy is going to stay the same. It's always going to have a constant number. The key energy that you're dealing with when you think of conservation of energy is the total energy of a system, which can also be referred to as mechanical energy, or ME. So mechanical energy of a system must remain constant. But what is mechanical energy? So mechanical energy is made up of kinetic energy and potential energy. So we remember potential energy is based on position. So you want to talk about an object that is on top of something. Okay, so that ball has potential energy, whereas kinetic energy is based on motion. So say this ball goes and falls off, now it's going to have kinetic energy. Okay, so what happens is potential energy is going to be greatest when the object is up high, at the highest height it can be. Whereas kinetic energy is going to be greatest when you are very, very close to the ground. In fact, kinetic energy is highest the moment you hit the ground. The moment between hitting the ground and stopping, that's when your velocity is the highest, that's when your kinetic energy will be the highest. Okay? So, there's also the fact that at the ground, potential energy, since there's no height, will be zero. So, potential energy plus kinetic energy is always equal to whatever your mechanical energy will be. Let's apply this to some problems so that you guys get a better feel for what's meant by this. So here we have a building, and it tells us our building is 20 meters tall. Okay, and there's an object on the top of this building, and it's a 5 kilogram object. All right, so we're going to apply this to some information and utilize conservation of energy to figure all of these pieces out. First question is potential energy before dropping the ball. So let's make some more room for work here. So if we want to find potential energy, we need mgh. Okay, so then we know our mass is 5 kilograms, h is 20 meters, and then g you should always know, 10 meters per second squared. Okay, so we're going to take those numbers. PE is equal to 5 times 10 times 20, which is going to be 50 times 20, which will be 1,000. PE equals 1,000 joules. All right. So we just figured out our potential energy. Now, question number 2 is asking us what is the kinetic energy before dropping the ball. Okay, so we need to remember KE equals 1/2 mv squared. So our mass is still 5 kilograms, but before you drop the ball, do you have any velocity? Hopefully you're saying no. Our v equals 0. So if we plug in a 0 for v, our KE ends up being 0. All right. So now we have a potential energy, we have a kinetic energy, we can figure out the last thing, ME. ME, or mechanical energy, or your total energy, is equal to PE plus KE, which is 1,000 joules plus 0 joules. All right, that means our ME is 1,000 joules. Once you have figured out your mechanical energy, you can use that number and apply it to any other situation as long as you're working with the same system. So as long as we're working with this 5 kilogram object and this 20 meter high building. This mechanical energy being equal to 1,000 joules is true for any situation we apply to the ball in the building, okay, or the object in the building. So let's apply something else to this situation. We're still working with our same 20 meter high building we have the same 5 kilogram object, but this time we're given that we're moving at 20 meters per second. Okay? And then this is actually happening at the very bottom. So this is when our ball has gone all the way down. It's moving at 20 meters per second. Okay? So let's find out our KE. So let's move this over. So we know M is 5 kilograms. We know V is 20 meters per second. Our equation is KE equals 1/2 mv squared. If we plug in our knowns, we're going to have 1/2 times 5 times 20. And the 20 is the only thing that's squared. So you're going to have KE equals 2.5 times 400, which is 1,000 joules. Okay? Now, another thing is we want to know what's our potential energy. This is going to be at the bottom of the building, okay? Which means our height's going to be 0 meters. So if H is 0 meters, G is still going to be 10 meters per second squared. M is still 5 kg. But since PE is equal to mgh, if we plug in a 0 for H, that means our PE is going to be 0 joules. Okay? So if we want to find our mechanical energy, or our total energy at the bottom of the building, ME equals KE plus PE, which is equal to 1,000 joules plus 0 joules. That gives us a mechanical energy of, once again, 1,000 joules. So whether you're figuring it out from the top or the bottom, mechanical energy is the same. Okay? Mechanical energy is constant. So even if you're doing something in the middle of the trajectory, once you figured out your mechanical energy once, you can use this mechanical energy at any point. All right? So let's away. In the middle, our object has gone down 10 meters. So, mechanical energy, what is it? I hope you are all saying 1,000 joules. We don't even need to do a calculation to figure that out. We've already done it twice. All right? So, our potential energy. We have enough information based on our knowns to figure out the potential energy again. Okay? So let's make some room. This is the same building we've been working with before, but this time we've gone 10 meters down. So if we started at 20 meters, all right, to find your height, it's going to be 20 meters minus 10 meters, which is 10 meters, okay? G is still going to be 10 meters per second squared, and our mass hasn't changed, so that's still going to be 5 kilograms. So PE equals mgh, PE equals 5 times 10 times 10, which is 500 joules. Okay? So that is our PE. Now we need to find our kinetic energy. Now, we aren't given the velocity, so you can figure out kinetic energy a different way. We know ME is equal to PE plus KE. If we want to find KE, we subtract PE from both sides. All right, so KE equals ME minus PE. And we know our mechanical energy, based on what we have written up here, is 1,000 joules, minus our potential energy, which was 500 joules. So our KE equals 500 joules. Okay? So now we have a known of KE being equal to 500 joules. We know our mass is 5 kilograms, and we want to know our speed or velocity, okay? Velocity is just a speed with a direction. All right, so if you're solving for speed, all you need is the number. So velocity, and when we rearranged that KE equation, you end up getting velocity being equal to the square root of 2 KE divided by your mass. So we're dealing with this set of knowns right here. We're going to plug in what we know. So we're going to have 2 times 500 divided by 5, which is 1,000 divided by 5, or the square root of 200, which the square root of 200 is 14.14, and that's units of meters per second. Okay, so if we go back up here, we now have our last piece of information, 14.14 meters per second. All right, so hopefully what you've gotten from this the following. 2 true things to keep in mind. ME, total energy, is equal to your potential energy plus your kinetic energy at all times. All right? You might have also hopefully noted that your mechanical energy is equal to potential energy at the top, okay? Because at the top, your height is greater than 0 and your velocity is equal to 0. So it's all PE. Whereas at the bottom, your mechanical energy is equal to kinetic energy. And that's because here, your velocity is greater than 0, but your height is equal to 0, so it's all KE. All right? Keep in mind, potential energy and kinetic energy are not equal to each other at all times. In fact, they're almost always not equal to each other, because at the top, you have all potential energy and kinetic energy being 0. The bottom, you have all the energy being kinetic energy and potential energy being 0. Okay, so what's not true, and don't let this trick you into something, PE and KE are not equal to each other. PE plus KE are equal to ME. So that's the end of this video. Be sure to complete the conservation of energy assignment by tomorrow morning at 7:20 a.m. I'll see you in class.